Hi viewers, this is Sri Ramlu. So my name is Sri Ramlu, degree lecturer in physics. My YouTube channel is yes space physics. So dear viewers, please subscribe this video before watching this, and don't skip it till the end of this video. Okay friends, let me start. Thermal conductivity. Thermal conductivity. In thermal conductivity, energy transportation takes place. So that is why in the bracket it is written. The conduction of heat through a gas is molecular process, right? So conduction of heat is because of molecular process only. When the molecules gain the energy and they moves lower temperature region and they collide with the lower temperature molecules and transport this energy. So that is why conduction of heat is through a gas is molecular process only. The molecules in hotter region of the gas have greater average energies, right? So the molecules in hotter regions, they have greater average energy is taken. Why? Because all the molecules cannot absorb heat energy more. Certain molecules absorb less heat energy and certain molecule can absorb more heat energy. So that is why we have to take here average value, right? And energy is always directly proportional to the temperature, right? Directly proportional to the temperature. That is why hotter region molecules are having greater average energy. Okay, hotter region molecules are having greater average energy. And energy not only directly proportional to the temperature, and also it is directly proportional to the square of the velocity. As the velocity increases, energy also increases. Okay, so the molecules in hotter region of the gas have greater average energies than those in colder region. Okay, comparing to colder region, the hotter region gas molecules having more energy, thus losing this excess of energy by implementing it to the colder molecules with which they collide. So how the energy lose the hotter region molecules? When hotter region molecules collide with colder region molecules, then this hotter region molecules can lose energy and gives to the colder region molecules. So like this, its energy decreases and energy increases, and after certain time they makes the balance. And next, thus the thermal conduction is the transportation of energy resulting from the molecular motion. Okay, in this manner thermal conductivity is the transportation of energy. So here because of energy transportation only thermal conduction will occur. Next, the phenomena of thermal conduction may be explained like viscosity. Already I explained viscosity and uploaded also along with the transport phenomena. Let us consider mass of gas at rest. Okay, at the beginning mass of the gas is at rest. Okay, now and AB, LM and CD be the three horizontal planes in the gas such that temperature increases as we go from plane AB to CD through LM. And see here, AB, LM and CD are the three horizontal planes. So it is a one horizontal plane CD, and LM is also another horizontal plane, and this one is also horizontal planes like this. And see here, as and next, in the gas such that temperature increases as we go from plane AB to CD. So as we go from this value to this side, down to top, then temperature what happens? Increases. Okay, like this three planes present through LM. So this is a middle, one more layer is there, layer of the gas, and this is called intermediate layer or intermediate plane, and all the three planes are parallel to the XY plane only. Next, this means that the gas above above the plane LM on the average is at a higher temperature than the gas below the LM as shown in figure. This means the gas above the LM having at a average it is at higher temperature and below at lower temperature. Let planes AB and CD, here this plane and at this plane, are at a distance lambda. See, this is a distance lambda from LM only. This is a distance lambda from intermediate plane LM. So I told you just now. LM is its name is intermediate plane. Thus, kinetic energy of the thermal agitation. Thermal agitation means because of presenting different temperature. Okay, because of different temperature of the gas molecules above the plane LM is greater than the kinetic energy of the molecule, kinetic energies of the thermal agitation of the gas molecules below the plane LM. So kinetic energy of the gas molecules above the plane LM is very much high comparing to this one. Okay, this side molecules having the low kinetic energy, average kinetic energy, and this side having high average kinetic energy, high average kinetic energy, low average kinetic energy. An account of thermal agitation, again because of temperature difference, there will be a continual transfer. So when the temperature difference occur, then only heat energy will transfer, right? An account of thermal agitation, there will be a continual transfer of more energetic molecules downward across LM. Alright, so because of presenting different temperatures, what continuous more energetic molecules they are transferring. Which side? Through LM side. So that means they are coming from top to downside, and less energetic molecules move upward direction. So less energetic molecules they moves like this, and more energetic molecules comes downside and they moves upside. Less energetic molecules. Next, thus there is a net transfer of energy downward through plane LM. Okay, so that is why net means difference amount of energy transfers. Which side? Downside through LM. That is the temperature of the gas above AB is falling while that of below rising. Okay, so what is happening here? Because of transferring the more energy molecule this side temperature increases and upside temperature decreases. Now in other words, gas is conducting heat downward across LM. Yes, gas conducting means they are allowing the heat energy from top to bottom, causing equality of temperature through the whole mass. Yes, so main theme of doing this one is what, to keep all the gas molecules should have the same temperature. For in this manner only higher energy transfer from high region to low region. And next, let n be the number of molecule per unit volume. So small n, what it is indicating? How many number of molecules present in 1 unit volume. Suppose in 1 unit volume there are 20 lakhs, then small n value is 20. And in 1 unit volume, let sometimes 30 lakhs also present. So its value is 30. So that means in 1 unit, how many number of molecules present, that is denoted by small n. And c bar is their what? Average velocity. See, c bar is the average velocity. That means all the molecules cannot move with the same velocity. Certain molecule may have the greater velocity and someone may have the lesser velocity. So that is why we have take average. When do we take average? When different velocities are there, then only we have to consider average velocity. That is average velocity because of what? Due to thermal agitation, because of presenting different temperatures at different regions with which they are constantly moving in all the direction. Okay, because of thermal agitation only molecules are moving in different directions. Suppose that 1/3 of molecules are moving in each three directions parallel to the three coordinate axis. Three coordinate axis. Coordinate means x, y, z axis are coordinate axis. Suppose one third molecules are moving in along the x direction. One third molecules are moving along y direction. Remaining one third molecules moving along z direction. So like this, because of thermal agitations only, that is. Next, so that and on the average, it is not average. See, this side is not. Here again we are taking average. An average. So an average, the molecules moves parallel to any one axis in one particular direction. Okay, an average means certain molecules may have the greater speed, certain molecules may have the lesser speed. So what I'm taking an average. An average, how many molecules they travel in each direction? 1/6. Instead of 1/3, 1/6 molecules travels. Okay, in particular direction. Therefore, the number of molecules crossing plane LM upward or downward, either upward or downward, per unit area per second. In 1 second, in 1 unit area, how many they are crossing? That is denoted by NC bar by 6. Right? Okay. So like this, NC bar by 6 will come. Let E be the average. E is the energy of each molecule in the plane LM. So in plane LM, where is LM plane? It is the intermediate plane. So how many molecules? What is the energy of those molecules? E. And dE by dz is energy gradient. That means what? Energy gradient means, so here like this we have taken three planes. It is LM plane, intermediate plane, and this is AB plane. Am I right? And above plane is CD plane. And as we move in this direction, temperatures are different. Just to we learned. So this region is hotter region and this region is colder region. So colder region having the lower energy, hotter region having the higher energy. That means as we move upside direction, as the distance changing, their energy also changes. When the energy depends upon the distance, then that is called anything which depends upon the distance, that is called gradient. Here energy is depending, that is why it is called energy gradient. Okay, so like this energy gradient comes in upward direction perpendicular to the plane LM. So perpendicular to the plane LM, upside energy is always positive. Why? Because more energy present. So that is why positive value is taken. But what is lambda? See here, where lambda is the distance of each of the plane AB and CD from the plane LM. See here the diagram. So this is the distance, right? And this distance, either this distance or this distance. And this lambda is called what? Mean free path. So I explained you mean free path. Once again, let me explain what is a mean free path. Let here one molecule is a gas molecule, and here another gas molecule, and here one more gas molecule. And let me take at this point another gas molecule is there. Suppose it is coming like this, it may collide here and later travel freely without colliding. And when it reaches to the next molecule, again here collision will take place. And suppose again it is moving this direction, it may collide this one, and here there is a distance. Okay, this distance is called lambda, or this distance is also called as lambda. Why? Because in between these two collision, again there is no collision, so that is why it is moving freely. So path means distance, and here to here it is also moving freely, so its path is also called as distance, but this path is more than this path. So that means the different paths are there. Then when we have the different things, we have take average. Average is also called as sometime mean. Okay, so that is why it is a mean free path. Free path means in between this collision there is no again any collision, so that is why it is freely move without collision. So that is why it is called mean free path. And next, energy of each molecule at a plane AB. So at plane CD it is a positive, at plane AB it is negative. Why? Because AB plane is downside, its energy is less, and a CD plane, at CD plane energy is more, so that is why here positive value is taken. Therefore, the energy carried downward by the molecules crossing unit area of the plane LM per second from the plane CD. From the plane CDC, average energy. So, energy carrying. So, per unit area, how much energy they carries? this much of energy they carry. Okay, so this is the energy present hotter region, and these are the total number of molecules, then it gives total energy in hotter region. Similarly, energy carried upward direction. Okay, so upward direction by the molecules crossing unit area of the plane LM per second from the plane AB. AB is the downside, CD is the upside. So the upside is positive, downside is negative. That's it only. Only this is the difference. Okay, and it is energy. And next, net energy. It is hotter region energy and it is a colder region energy. It means it is upside energy and it is downside energy. Net energy transfer downward per unit area of the plane lm per second. So here net energy, if you want net energy, subtract the value from this to this, means a higher region, higher energy to lower energy. Okay, then what do you get? So if you multiply it, simplify it simply. So multiply this one with this one and with this one also, next with this one and with this one also, then you will get cancel first terms and the remaining time will add up. By adding 2 you may get 2 ones are 2 threes are, so that is why here 3 will you get. Okay friends, like this we get this one. Next, but E is the heat energy of a molecule mcvt, where cv is the specific heat of the gas at constant volume and T is absolute temperature. See here, energy, how this formula has come. So from the specific heat formula. So what is the specific heat formula? Specific heat is denoted by C and it is written as dq by m into dt. We write it is like this. But instead of q is a heat energy generally. So instead of q, what we have taken here, energy we taken as E only. Am I right? E by m is as it is, and instead of dt, what is taken, T is taken. So C is equals to E by mt. All right, C is equals to E by mt. Yes, m into T. But if we keep here V, it indicates at constant volume. Okay, so now bring this to this side, then energy can be written as, from this energy can be written as E is equals to what, if these two goes this side, then mcvt. So that is why mcvt is taken, and replace this E value with this one, then here we get this one. And among them m and cv are constant, T is changing. Why? Because T changes. If you see the diagram, it is a hotter region, it is colder region, that means here temperature less, this side temperature is more. That means as we move from down to up, temperature changes, means increases or changes. So changing means only T value changes, T value changes, then remaining quantities are constant. Bring them this side, then you get last final one, this one. And the next, the coefficient of thermal conductivity K. So thermal conductivity is denoted by letter K of a gas is defined as the ratio of quantity of the heat transferred per unit area in 1 second to the temperature gradient. Okay, so this is the important definition. By using this definition only we can calculate thermal conductivity. Once again, thermal conductivity of a gas is defined as the ratio of, means there is a division line, quantity of heat quantity is this one, net heat transferred per unit area in 1 second. Two means division line, the temperature gradient. So temperature gradient, I told you gradient when we take, when quantity depends upon the distance, so that is why dt by dt. Z means it is now changing along z direction, so that is why dz is written. Okay, now these two gets cancelled. What is this is only remains, and that is written downside. Am I right? K is equals to 1 by 3 m and C or C V C V lambda. But lambda is a mean free path, that is already we have the formula, that is 1 by root 2 pi d square n. And take this value and substitute and then simplify, then what happened? So finally you may get this one. This is the thermal conductivity formula. Okay friends. So watch it till the end. Okay friends, thank you very much.